polyatomic ions. All right, and your polyatomic ions are just our nonmetals that are covalently bonded. So just as you would use for a monatomic ion bonding situation, you're going to use the same thing for a polyatomic bonding situation. So if you had, again, sodium, which is in group 1, it has a +1 charge, and you reacted with SO4, 2 negative, which is sulfate, then you're still going to use the same crisscross method in order to build the compound. So the 2 from the sulfate is going to go to the sodium, and the 1 from the sodium is going to go to the sulfate. Now, something special about polyatomics. When you have more than one polyatomic ion being represented, you're going to place that polyatomic ion in parentheses, all right? Remember, don't break them up. They are a family. They're covalently bonded together, so you can't put your numbers in between these two elements here. So the correct way to write it is going to be Na2SO4, okay? Now, you only have 1 here, so therefore that's the only reason you have SO4 here without it being parentheses. If you had calcium, which is in group 2A and has a 2+ charge on it, and you react it with PO4 3 negative, which is a phosphate ion, then you're going to see that you're going to put the phosphate ion in parentheses because you're going to have more than one phosphate ion. So this compound will look like this: Ca3, open parentheses, PO4, close parentheses, 2. Okay, so you can see that, again, if there are multiple ones, you put them in parentheses. If they're single, then you're not going to put them in any parentheses, okay? Now, the overall gist of your ionic compound is that it has to be neutral, okay? So in order to check and make sure your compound is neutral, you take the charge and you multiply it by the number of elements you have. So in this case, I have 3 calcium, each one of them having a 2+ charge, and that gives me 6+ here. And then I also have my phosphate, and I have 2 of those, each one of them giving a -3 charge, which gives me a -6 here. So 6 plus a -6 makes this compound 0, and it is neutral. So I know this is the correct compound for the reaction of calcium and the phosphate ion. Now, let's talk about how we would name it while we're learning how to build them. So, your cation in your naming always goes first. So, remember when we talked about ions, our cation takes the name of the element. So, this would just be sodium. Okay, and since this is a sulfate ion, then you just take the name sulfate. So it's going to be sodium sulfate. Same thing here. You're going to have calcium. And in this case, instead of having a sulfate, you're going to have phosphate. Now, if you had single elements ionically bonding together, as the one we did earlier, which was Na2S, then you would name this one. Take the name, cation takes its name of the element, sodium. And this is an anion, alright? And we always take the root of the element name and we add IDE. So this will be sulfide. Very good. Okay? Guys, any questions about ionic compounds and naming ionic compounds? Because we're going to practice, alright? So take out your practice sheet. And the first thing we're going to do is we're going to do some Lewis dot structures showing how the electrons are transferred through ionic bonding. So I'm on your in-class practice, and I'm doing number 1A, and it says you have barium and nitrogen reacting. And it wants you to do Lewis dot structures and do the formula unit. So the first thing we need to do is find out what is the symbol for barium and what is the symbol for nitrogen, okay? We look at our periodic table. We know barium is in what group? 2. Group 2, very good. And what's the symbol for barium?
BA.
BA. Very good. Okay. How about nitrogen? What group is it in? 15. Or group what? 5. All right. And what's the symbol for it? N. Very good. Okay. Now, let's try to find how many valence electrons we have for each one of these elements. Now, remember, for our cations, the number of valence electrons is also the what? Group number. So how many valence electrons should I have for barium? 2. Very good. Now for our nonmetals, how do we find the number of valence electrons? The number of valence electrons again is the what? Group number. So how many valence electrons should I have for nitrogen? 5. Very good. Okay. Now, we see this, right? So we're going to have these two things being bonded together. Alright? Now, before we do that, we know our valence electrons, we have those here. An easy way to figure out how many barium you're going to need for every nitrogen, because you see barium only gives how many? 2. Alright? So this one nitrogen will take the 2 barium electrons, but he still has one that he needs, correct? So let's do the formula unit first, and then we'll do the Lewis dot. Okay? So tell me this. What's the charge on a barium? For a metal, the charge is given by the what?
It's the
charge on a metal. It's given by what? Remember our definitions for metals and cations, how we find the charge. It's given by the group number, right? So write this down. Make sure you remember metals. You get the number of valence electrons and the charge from the group number. Yes.
So it's going to be 2?
Yes. Plus 2. Very good. All right. For our nonmetals, we get the number of valence electrons from the group number, right? And we get the charge from the group number minus 8, right? So we said nitrogen was in group 5. That's what you told me. So what's the charge on the nitrogen? Minus 3. Very good. Okay. Now, knowing this information, all we have to do is use the what method? Which method? Crisscross method. All right. And if we use the crisscross method, we know we're going to have 3 barium for every what? 2 nitrogen, okay? So that's our formula unit here. Crisscross. Barium gives 3. Barium gets 3. Nitrogen gets 2, okay? So now we know that we need 3 barium for every 2 nitrogen. Now can we move our electrons to the Lewis dot? Yes, okay? So I'm going to do that in another color. So we know barium. We're going to have 3 barium, each one of them having how many valence electrons? 2. All right, and then we're going to have how many nitrogen? 2. Each one of them having how many valence electrons?
Is it 3?
5.
5.
Alright. Now, do you see space for barium to give away its electrons to nitrogen? Yes. You got space here, here, and here. Each one of them can take 1 electron. So remember, we do our circles, and we're going to follow it. So that means the electron goes there, circle, here, and the electron goes here, circle, and then the electron goes there, circle, and then the electron goes here, circle, electron goes here, and then this circle here, and that electron goes there. So now everybody has gained what they needed and given away what they needed. Barium has given away its 2 electrons, and nitrogen has greatly accepted them. All right? So what's our next step in our Lewis dot? Right? Our arrow, and we're going to say it's going to be barium 2 plus, barium 2 plus, barium 2 plus, and that's going to be added to our 2 nitrogens that now has, instead of 5 electrons, it has what? 8. Very good. Okay, and that's going to be your Lewis dot. So here's your Lewis dot here. And here's your formula unit. Alright, so what we're going to do is we're going to work in groups, and we're going to work problems 1, B and C, and D and E in a group, alright? And then you're going to compare your answers to each other. So I want to see formula unit, and I want to see Lewis dot from everybody. So let's get in our groups, and we'll start working our in-class practice.